Hey guys, welcome back. So today I'm just going to try to explain why a definite integral is what it is and how it works a little bit better. Okay, if you would like to check your memory, try these problems from, yesterday and the day before. So hit pause, do these as a little mini quiz if you'd like to. There's nothing new here. This is just a quick quiz of your memory. Okay, the first one, remember now, the integral of sine is negative cosine. Leave the inside the same and divide by the derivative of the inside. Okay, number 2 is an STD, a single term denominator, which means you can split it up. So we're going to put 3x to the fourth over x squared, subtract, and that's 3x squared. This guy would be 2 over x squared, and I'm going to, in order to integrate that, I'm going to have to move the x squared to the top and make it a negative 2. And the last term would be negative 5x over x squared. That would simplify and we'd have a negative 5 over x. And I'm not going to move that one to the top because hopefully you remember that this one is not really a power rule. Now remember that the integral symbol means you still haven't done your calculus. All you've done is algebra. So now you still have to integrate and do your power rule. The first one would be 3x cubed over 3. So that's just going to be an x cubed. This one, when I add 1, I get negative 1. Divide by negative 1. So that's going to be a negative 2x to the negative 1. And I'll move it to the bottom to make it a positive 1. This guy is a natural log. So it's negative 5 natural log of x plus c. Okay, number 3 is just a little bit of everything, quizzing your memory. The first term, add 1, you get a 5, and divide by 5. So that's going to be a negative x to the 5th. This guy is 4 e to the 2x divided by 2, because you're dividing by the derivative of the inside, which gives you 2 e to the 2x. And the last one, pure memorization, 3 to the x divided by the natural log of 3. Plus c. One more, the last one. The integral of cosine is sine, positive. So this is 2 sine of 3x divided by 3. So that's just a little quiz. By the way, this is the majority of what your actual quiz is going to look like. All right? So now moving on. We did this integral. We actually did this one twice yesterday because I failed to mention something. So you already know how to do this integral. Go ahead and give it a shot on your own if you'd like. And I'm going to try to explain the meaning behind it. So we integrated. We got x squared. We don't need the plus c for definite integral because it would just cancel out anyway. Plugging in the 2, we'd get 4. Minus, plugging in the negative 1, we'd get 1. And this is an answer of 3. Okay, so now I want you to remember that we got an answer of 3. Next, I'm going to go to the graphing calculator and show you how to put this into the calculator. And then I'm going to try to get you to figure out what it's really doing. Okay? Okay, so to put this integral in the calculator, there's 2 different ways of doing it. Right now I'm going to do it graphically because I want you to see what it's doing for you, but there's a quicker way that I'll show you later when you actually want to use your calculator to get the answer, not look at what it means on a graph. Okay, so I'm graphed just the line y equals 2x. So this is just the line y equals 2x, okay? And you can see it has a y-intercept of 0 and a slope of 2 up 2 over 1. And that's where that line came from, okay? Next, I'm going to do the integral of that. So right here above trace where it says calc, we're going to hit second and calc. And then this will pop up. We're trying to integrate, so we're going to hit option 7. Okay, the next thing that pops up, after you hit option 7, it's going to ask you for your lower limit and your upper limit. Your lower limit is this guy. It's not necessarily the smaller number always. It's just the number that's on the bottom. So I typed in -1 for my lower limit. Then it asks me for my upper limit, and I'm going to type in the 2. Now I want you to see what the integral of the 2x, what it's going to do to this graph of a line. What will that integral actually change on that graph? So after I hit enter, this is what I get. And remember, we already said the value of this integral is supposed to be 3, and the calculator also says it's 3. But look at what it did. It kind of shaded in some stuff. Okay, so now I want to focus on that. Where does this 3 come from? It's clearly the area of that shaded region, but what is the area of that shaded region? So that's what we're going to focus on right now, just so you can get a conceptual idea of what this integral really is. And in the future, we're going to use this quite a lot, okay? Okay, so work with me here. We want to figure out, where does this 3 come from? I'm going to try to calculate the area of this triangle right here, okay? Well, this has a width of 2. And let's see, what is that height right there? The reason it stops at 2, by the way, is because this is at 2. So we went over 2. And if I want to know how high up that is, I could plug in a 2 to the equation of that line, and we'd get that that's a height of 4. Okay? So this triangle is over 2 and up 4. So the area of that triangle would be 1/2 of 2 times 4, which is 8. So the area of that larger triangle is half of 8, or 4. So this triangle has an area of 4. Okay, now let's do the same thing with the little triangle. The little triangle has a width of 1, and that's because we actually started at -1 right here. This integral is doing the area from -1 to 2, because that's what the -1 and the 2 do right here. Okay, so it's a width of 1 and a height of, I think that's 2, but to be sure that that's 1/2, remember, this line is just the equation y equals 2x. So if I plug in x of -1, you'd get that y is -2. So I know the coordinates of this point are -1, -2. So moral of the story, if we zoomed in, you could figure it out anyway. This triangle is 1/2. All right, so the area of that triangle would be 1/2 of 1 times 2. So half of 2, which is 1. So let's try to put it all together. We remember that the answer to this question is 3, and here it is. Okay? The integral from -1 to 2 goes from here to here, because this is a -1 and this is a 2. The area of this triangle was 4, and the area of this triangle is 1. So what do you think is happening to get that answer of 3? In other words, what does this integral actually mean? Okay, it is the area under the curve, or the area between the curve. We call it a curve even though this one's a line. It is the area from the curve to the x-axis. And if the area is above the x-axis, then the integral assigns it a positive value. If the area is below the x-axis, the integral assigns it a negative value. So this is -1 plus 4, and that's why the answer is 3. So what I wanted you to get out of this is just an intro. We're going to do a lot more with this. I kind of want you to recognize that the integral means the area between the curve and the x-axis from -1 to 2. Okay? So that's what the integral is actually doing. So we know derivative. The derivative means slope of the curve. Integral means area under the curve. That's all I wanted to show you, is what it means. Even though you don't need that yet for your next test, it's important that we at least start with that concept. That's what we're going to be doing more of next week. So now if I just made up a random curve, let's say blah, 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 something like that. That's lovely, I know. And I call this f of x, and I ask you to integrate f of x from, let's go from like 0 to 7. Well, this is 0. Let's say 7 occurs right here, okay? If I asked for that integral, that would mean I need to find what is this area and what is this area, okay? And obviously we can't do that right now because it's a curve, it's not a straight line. But if I told you, oh, and by the way, this, let's say this is a 1 right here. If I said the area from 0 to 1 was 4, and this area down here is maybe, oh, I don't know, that's an area of, say, 7, or make it 6, whatever, who cares? If I asked you to integrate that just with that picture, you would just know that that would be a 4 and a negative 6, and the answer is negative 2. Okay? Similarly, let me give you another one. Let's say I asked you to integrate. Let me change these bounds. We call those bounds. Let's see. Let's say, gonna have to start fresh. Let me hit pause and give you a new picture. So if I gave to you that the area in this region was maybe that's 8, making stuff up, and I give you that the area of this region is maybe, I don't know, 6, making stuff up, and I said, what is the integral? Be careful now, I'm going to try to trick you. What is the value of the integral of f of x from 4 to 7? Okay, well, that area is 6, but since it's below the x-axis, we would say the value of the integral is negative 6. So an area can never be negative, but the value of an integral can certainly be negative. Using the same problem, if I said, what is the integral from, let's erase the bounds. What is the value of the integral from negative 3 to 7? Then you would say that it's positive 8 and a negative 6, so that would be 2. Again, you don't really need to know this yet for tomorrow's test. I'm just trying to make sure I at least explain what the integral actually represents, and we're going to work a lot more on that next week. So your homework today is really just to review. It's all the problems in your book. Make sure, that's not even it. Make sure you review all of the worksheets I've given you, because those worksheets are very, very, very similar to your quiz. Tomorrow's quiz should be really an easy A, as long as you've studied and practiced all of the problems on those worksheets. And in addition to the worksheets, you do need to know how to evaluate a definite integral. Okay, good luck, guys. Hope you're doing well. Bye.